Okay, so we're talking today about practical applications of trigonometric ratios, specifically solving right triangles and how to use angles of elevation and depression. These angles are, well, we'll talk about them when we get there. What we need to do first is we need to remember all the tools that we have available to us. We have the Pythagorean theorem, we have the angle sum theorem, we have SOHCAHTOA, which is the trig ratios, and then we got to remember that we use the trig ratios to find side lengths, but we also use inverse trig ratios to find angles. Those are actually underneath SOHCAHTOA. So we can find angles given side lengths, we can find all of this stuff. So on this one, what they have given us here, let's say this is triangle ABC. What we have in triangle ABC is we know that AB is equal to 3. We know BC is equal to 5. We don't know AC. But since we have two of the three sides, we could definitely use the Pythagorean theorem on this. We also don't know the measure of angle B, and we don't know the measure of angle C. We know the measure of angle A, though, is equal to 90. But we don't know these. So this one, we could solve this a specific way, and we may come back to it here in a second. Let's say this is triangle XYZ down here. And in this one, we know the measure of angle Y. Oh, I should have also given this a side length. Let's make this 5. We know the measure of angle Y is 65 degrees. We don't know the measure of angle Z. We know the measure of angle X. Measure of angle X is 90 degrees. We don't know any of the side lengths other than XY. We know XY is equal to 5, but we don't know YZ, and we don't know XZ. So starting by listing the information that we have and remembering we have these tools, the Pythagorean theorem, angle sum theorem, which is equal to 180. This is a squared plus b squared equals c squared, and SOHCAHTOA will help us. Okay. All right, solving right triangles. So to solve these right triangles, what it means to solve a right triangle, I need to write this down, is that you find all the unknown sides and angles. You find every bit of the triangle, given what you know. So what I previously did was I identified the missing info. That's what you're going to do first. You're going to identify the missing info, then you're going to use all available tools. Now on this one, they give us two sides. And so we should in our brains already know that we can use the Pythagorean theorem. And on the second one, the triangle DEF, they give us one angle and one side. And so we should already know on this one we can start by using trig ratios. So let me work those examples with us real quick. Here's the first example. To solve this, we know AB equals 10. We don't know BC, and we don't know AC. We'll find those, though, throughout the process. Oh, we do know BC. BC is 24. But we don't know AC. So then we can actually say a squared plus b squared equals c squared. So let me throw up my calculator over here. This was going to be the square root of 10 squared plus 24 squared. All right, so it's 26. So AC is equal to 26 in this case. Now, I also need to find the measure of angle B and the measure of angle C. Oh, sorry, measure of angle A. We already know B. B is 90 degrees. So let's go ahead and find angle A because we know all of this information. We know this is now 26. So if we're looking at angle A, we can use any of the trig ratios. As we talked about before, it doesn't matter. I'm going to use tangent. I'm going to use the opposite over the adjacent. So opposite over adjacent is 24 over 10. So remember, to find an angle, we have to use inverse tangent. So I'm going to take tangent -1 of that, and that'll give me the measure of angle A. So inverse tangent of, oh, why did it go backwards? Tangent -1, 24 over 10. 67.38 degrees. So angle A is, let's round it to 67 degrees. Now finally, to find the last angle over there, to find angle C, all I have to do is subtract it from 180, because I know that there's 180 degrees total, so I'll take 180 minus 90 minus 67. That gives me 23 degrees, so this one is 23 degrees. Now I have officially solved this right triangle. I found all 6 parts. 1, 2, 3, 4, 5, 6. All right, let's move on to the next example. So in this example, DE is given to us. We already know DE is 25. And we don't know EF. And we don't know DF. So we're not going to be able to use the Pythagorean theorem on this. We do know the measure of angle D is equal to 40 degrees. And we know the measure of angle E is equal to 90 degrees. So we can already find the measure of angle F. If this is 40 and that's 90, then we can do 180 minus 90 minus 40 to tell us what the other angle is. So it's 50 degrees. So we can go ahead and put in 50 right in there. Now, the other side links, in order to find, let's say we're going to find EF first. To find EF, we're going to have to use a trig ratio. So let's look at angle D here. Knowing that we have the adjacent and the opposite, we're going to use tangent. Okay, so tangent of the angle, tangent of 40, is equal to x over 24, or 25. So I can solve for x now simply by multiplying 25 on both sides. So x is equal to 25 times the tangent of 40. So 25 times the tangent of 40 is 20.97. So let me just make that 20.98. So that side link over here is 20.98, which is EF. Okay, so finally, to find DF, I could use a trig ratio again, or I could do a squared plus b squared equals c squared, since I know 2 of the side links now. So I'm going to do 25 squared plus 20.98 squared equals c squared. So in my calculator, the square root of 25 squared plus 20.98 squared. And get my total answer of 32.64. Okay, sweet. That is the first part of this lesson, how to solve right triangles. Remember that solving means finding all parts.